Hello, so in today's video, we're going to look at something which you may not have seen before. So the modulus or absolute value of a number. So you may have seen these like straight vertical lines with numbers or algebra in the middle between them. So this is the modulus or the absolute value of a number. So for example, here, this example there, we would read this as the modulus of 2 or the absolute value of 2. So some people call it absolute value, some people call it the modulus. So what does it mean? So the modulus of the number 2, I mean, the answer there would just be 2. The modulus of minus 10, that'll be 10. The modulus of minus 10 times 7, well, minus 10 times 7 is just minus 70. And the modulus of minus 70, I'm going to tell you that that's 70. So, okay, I haven't really told you this, but what is the modulus of a number? So the modulus of a number is just basically the size of that number. That's the way to think about it, or how big the magnitude of that number is. So I'll just write this over here. So the modulus of a number is the magnitude. So the magnitude. Sorry, let me write that again. So the magnitude or the size of the number. That's one way you can think about it. So modulus is the number. Sorry, of a number is the magnitude or the size of that number. And regardless of what sign it is, so regardless of whether it's positive, negative, it will always be a positive number. So always, well, about a non-negative number. So the modulus of 0 would be 0. I'll just write this down here actually. The modulus of 0 is just the number 0. So always a non-negative. Let me write that again. Non-negative value. So yeah, the absolute value, the modulus, is just basically the magnitude, how big that number is. So if it's minus 10, the size of minus 10 is just 10, because we've got a magnitude 10. The same with the rest of these other examples here. So if we go to the next page, one thing that I've just noted here, especially with this third example here, just carrying on from that, is that the modulus of minus 10 times 7 is the same as the modulus of 70, which we know is 70. But if we notice, the modulus of minus 10 times by the modulus of 7 is actually just 10 times 7, which is also 70. And that's the same as this original thing up here. So it's the same as the modulus of minus 10 times 7. So one fact about modulus, the modulus function or the modulus operation, is that the modulus of a times b is equal to the modulus of a times by the modulus of b, where a and b are real numbers. So that's just something to bear in mind. And this will link into these 3 or 4 rules, that we have here. So the modulus of a number times by a number is just the modulus of that number multiplied by the modulus of the other number. And again, I'll just make clear that a and b are real numbers. So a, b are real. How about this one here? So again, similar kind of thing. So the modulus of a over b is the same as modulus of a over modulus of b. And again, I'll make a point clear here that b does not equal 0, but a and b are real. Okay, so then how about, sorry, I just rub this out here just to make that look a bit neater. How about this second one here? So it is not true that the modulus of a plus b is the same as the modulus of a plus the modulus of b. I mean, we can just look at an example like this, for example. So the modulus of minus 2 plus 3, well, that equals the modulus of 1, which is equal to 1. But the modulus of minus 2 plus the modulus of 3, well, that's equal to 2 plus 3, which is 5. And that does not equal this there. So the key thing is that this does not equal the modulus of a plus the modulus of b. However, we can actually use an inequality sign instead. So the modulus of a plus b will actually always be less than or equal to the modulus of a plus b. Sorry, the modulus of a plus the modulus of b. And a similar kind of thing with this one here. Again, you can just plug in some examples and check that this works. The modulus of a minus b is actually greater than or equal to, for all a values and all b values, the modulus of a subtracts the modulus of b. And these two results here are true. So true for all A and B. Remember this upside down, A just means for all. So for every A and B real numbers. So this is always true, these two results here. So sometimes these are called the triangle inequalities. I'll just make a note of that's down here. So triangle inequalities. You don't really need to actually know this for A-level maths, really. I mean, this doesn't really come up much, but it's just worth bearing in mind, maybe for the future, that these are normally called the triangle inequalities. However, the key two ones you really need to worry about will be these two there. But it's just worth knowing that A plus B does not have an absolute value as the same as the modulus of A plus the modulus of B. As we can see from this example up here, that doesn't work, but these two ones do work, these first two. There is equality with the left-hand sides and the right-hand sides. So yeah, that's how moduluses or moduli work, I should say. Again, the modulus of a number is just the size or the magnitude of that number inside the straight vertical line brackets.